Thank you. Can you hear me okay? Good. First off, I want to thank all of you and the organizer for inviting me today. I think this is my very first conference since before COVID. So I'm very happy to be getting out of the house and meeting you again. So thank you for that. I'm not going to talk about fair share. This is going to be a more technical discussion about DNS resolution in the EU. That's a paper I wrote, and I wanted to share some of the conclusions and maybe open up some conversation on this. So I suppose you all know how DNS works, right? When you have somebody who type in something, then this is sent to a resolver that does recursive things, and then the authoritative server receives one query and responds. And then this goes back to the browser usually and can connect to the IP address. Well, it's not how it works. That's what we teach, that's what we tell, but now we understand this is not really how it works. Next. Mike, there you go. So, when I started to write this paper, we were hearing all kinds of things, and it was part of some of the EU conversation about the respective weight of some of the big external players. We heard things like, oh, Google owns 80% of the market of DNS resolution. I thought, maybe let's check this. So we went on a campaign to do some measurements, and what we wanted to do is to provide some reliable data. It's not about providing an opinion, it's providing data. So there's a URL here, if you want to read this paper. We have another project called ITHI, which is Identified Technology Health Indicators, and we are now tracking this month after month. So you want to see the trend, you can go there. So most DNS resolver operators do not provide publicly statistics. So that's difficult to really get a view from that. We need to have an external measurement system. And there are a couple of things to keep in mind when you do an external measurement system. The first one, if you do a one-off, you're going to see what's happening that day. That may or may not be representative of what's happening every other day. The second thing is, if you have a couple of probes in different parts of the world, well, you know what is happening in those couple of places in the world. You don't necessarily know at scale what's happening. Because you need to have a statistically large number of measurement points. We're not talking about a couple of hundreds, a couple of thousands. Here we are running millions of measurements per day. And we do that every day. And then we average every month. So we try to smooth out what are the daily patterns. What's happening on a Sunday is not the same thing as what is happening on a weekday, because, well, at least pre-COVID time, people were at home on weekends and were in the office in weekdays, so there's a different pattern. Same thing during the day, after 5 p.m., well, things are different. So we try to smooth these things out. We did a partnership with Jeff Houston from Lipnik, that I'm sure all of you know, to have access to some of those measurements. And that's where I go to my question of the DNS doesn't work the way we believe it works, or at least the way we teach it works. Well, first off, when you have a machine, you have a resolver configuration file, a resolve.conf. You can have multiple resolver listed there. How is your system going to use this list? Is it going to do a round robin? Is it going to try only the first one, and if it fails, go to the second one? Or is it going to be random? Well, different systems have different behavior. Some apps also bypass this entirely and do whatever they want. Now we also see that queries are replicated. When we look at the resolver side, we don't see one query coming for a unique message. We see sometimes 2 or 3 or 4 or 5 or even more. And that's kind of weird. We also see queries coming a day later. So We have things that are completely unique. It's an ad-based system, right? And we ask every ad to essentially look up for a name that's absolutely unique. And we see the exact same thing coming a day later, or more. Why? That's not entirely sure. So, in the end, when I'm trying to measure those things, the real question is, what are you trying to measure? And there are really two different perspectives here. One is to say, which is the resolver that people are actually using? And if they are using multiple of them, well, we are going to believe that the very first response that they receive is the one that they are going to use. It's an educated guess, maybe I'm wrong, but I cannot believe that most of the time this is the case. So if I try to measure this, which one are you going to use? I'm going to say this is the very first response you get. So if I'm on an authoritative server, I'm seeing 5 queries. I'm going to respond 5 times. I'm going to only look at the very first response that I'm going to send. And I'm going to expect that if I send 5 responses, the very first one that I send will arrive first. Again, I'm making assumptions that may or may not be true, but on average, they should be true. Especially if there's one day later, right? The first one should be arriving first. So that's this, which resolver are you using? Another way to look at it would be, who is seeing your queries? So if I receive 5 queries, where I should only get 1, then actually 5 people, at least 5 resolvers, are seeing your queries. In this particular study, we decided to focus on operation and not on privacy. We could do a subsequent study focusing really on the privacy side, but this is for future works. So the perimeter here will be operation. It will be in the EU mostly, and for consumers. And you're going to see why this is important. So, all right. It's not that we don't have any open resolvers in the world. There's the current list of what we are seeing. There's about 40 of them. And there are some in different countries. Some are any casted in multiple places, of course. But it's not that there is a market failure of providing a number of open resolvers. There's choice for people who want to do something. So if I look at this worldwide, what I see is that about 20% of DNS queries are being resolved by open resolvers. Not 80%, 20%. And the rest, 80%, is essentially done in country. There's 79%, and there's like 1% that is done outside of the country.
I think this is the distinction you probably need to be making, since most of the recursive resolvers are.
Can you say who you
I have to look up. In this case, wearing a quad 9 hat, I guess. So, I mean, for quad 9, 90-some% probably, I'm just talking off the top of my head, are resolving in country, right? They're not crossing a national border. So I think the distinction between a public resolver versus a carrier-provided resolver is the distinction you're making here, right? The 80 versus 20.
So that's a very good point. So in this study, what we do to address this point is that we first count the ones that are for public resolvers, open public resolvers. And when we remove those, the rest we separate from in-country versus out-of-country. So this could be in-country or out-of-country.
The 0.9 is out of country.
Correct.
Got it. I'm sorry.
Correct. But you are absolutely correct, because sometimes open resolver could be in-country or out-of-country, and we decide to group all of them together. Because what mattered to us was, is it an open resolver or not? So if it is an open resolver, we identify it first. It's in this bucket. If it's not an open resolver, it is in the rest of the bucket. And here we see that most of it is done in country. There's a little tiny portion that is done out of country. And maybe this is a conversation that we can have later on around a beer to figure out why this is happening. If you look at the open resolvers, here you see that Google Quad 8888 has the lion's share of the market. And then you will find Cloudflare, Open DNS, Level 3, Quad 9, and then the rest of this list of 40 resolvers is really in the noise. Now this is worldwide. Zoom in to the EU. We see a different pattern. This 20% is down now to 12%. The distribution of the open resolver is more or less the same, but the proportion to the total market is a lot smaller. Same thing, we also see a little bit of out of country. And then we had an idea, which is to say, when there are business ISPs, and there are consumer ISPs, B2B, B2C, and there are things of different sizes. So we tried to somehow categorize all those things. And yet in our surprise, if we look at the large ISPs in Europe, what we see is only 4% of their subscribers are using an open resolver. 96% is using either in-country or this little portion of out-of-country. Which means that most people from big ISPs are using a provider-provided resolver. And that kind of makes sense, because if I give a phone line bill to my parents, they are not going to go and run the app to go and change it. Most people don't change any of those public settings. They just use whatever it comes with. If we look at the distribution here of the public resolvers, yeah, it's kind of the same thing, more or less. If I look at the small consumer ISPs, I see a different pattern. This is not 4%, this is now 36%. If I look at B2B, it now goes to almost 40% that are using open resolvers. The proportion, again, within the open resolver is more or less the same. But now 40% of people are using this open resolvers. And the share of out of country now going to almost 4%.
Out of EU.
Excuse me?
Out of EU.
Yes.
Even
Yes.
further.
Yeah, you're absolutely right. This is out of EU, not out of country. You're correct. The in EU is relatively small. I'm not 100% sure, but I believe that this is because we have multinational countries, multinational companies, I mean, not multinational countries, that means nothing. Multinational companies, and they are sending all their DNS traffic back to their headquarters. That's one hypothesis. Maybe there's another one. We'd like to hear it. So, well, clearly there is a difference in between the different type of providers. But the number one thing is this thing that we heard that Google has 80% of the market. And it's actually not true. If you're looking at consumers and large ISPs, they have maybe like 2/3 of 4%. Okay, maybe 2%, 2.5%. That's it, right? But really this difference between large and small consumer ISPs and business ISPs is something that's of interest. So we have a couple ideas as of why. Business ISPs tend to be more managed network, so it's not surprising that somebody is actually going to configure their resolver, DNS resolver, to go somewhere, or it could be some maybe cloud-hosted services, and they provide a pre-configured public resolver as a service, and it just comes with a package. We also talked to some of those providers of open resolvers, and they say, well, they have a package, it's kind of a security package, and they provide DNS resolution as part of it, and they target really to commercial companies, enterprises. So this is not really surprising there. What's more surprising, at least to me, was that small ISPs rely a lot on, small consumer ISPs, rely a lot on open resolvers. And if I look at some other countries outside of Europe, trying to explain the difference between this EU view and the worldwide view, we see that in many, many countries, we see almost 100% of the traffic being done by outside ISP resolvers, meaning out of countries or open resolvers. So it almost looked like there is an ISP-wide decision to not offer DNS service, even though they may actually send you DHCP and the local server, but simply forward this to somebody else. Like one of the open resolvers may have a contract with the ISP saying, oh, DNS is complicated, we will do it for you, don't worry. Is it a good thing or bad thing? I do not know, and it's not my job to tell, but my job is to notice that this is happening. So, oops, here it is, and I would love to hear some comments or some discussions around the beer later tonight. Thank you.
Thank you, Alan. Do we have any questions? Frederick? Yes, yeah.
Hi, Frederick Nathode. Do you have any idea about self-hosted recursive resolvers?
In consumer networks?
Yeah, or anywhere.
Well, self-hosted in consumer networks, they will be there. So they will be lost somewhere there. This blue thing.
Yeah.
And all I can say, it is not a lot.
Yeah. Thank you.
And Alexei, do you have... I thought you did. Oh, sorry, Ben.
No, we look alike.
I know. I remember when you get blonde hair.
You were close.
Who are you?
A couple of anecdata.
Who are you?
Sorry, I'm Ben from BGP Tools. Two anecdata things. One, I found that like corporates really do like to tunnel everything DNS-wise back to their HQ, mostly around things like DNS logging for instant response. The easiest way to do that is to send it. So, for example, all the Microsoft stores in London to take all their DNS back to Redmond, because I guess that makes sense. Two, I've noticed, especially things like WISPs, really like using Google DNS because I guess they just don't have that much infrastructure on hand in their normally decentralized networks. So the easiest thing is just to send to consumers quad A and call it a day.
I do have actually one question.
Okay.
So hi,
And
it's
you're...
Alex Silvanen from Finland. So at the beginning part of your presentation, you mentioned that sometimes you get those unique queries a day later. I have one theory what could be causing those. So I understood that your data collection method was based on web apps. So if somebody has one of those web pages open in a tab and their computer goes to hibernation, or they upgrade their browser version, for example, it closes all Windows and then reopens everything again. If that happens a day later from their initial going to the website, the restarting browser will partially refresh all those tabs, and that could be causing a query a day later.
It could, but I don't think it would, because when it refreshes, you get a new URL, a new unique URL.
I guess, but the way the browser refreshes is not a complete refresh.
Correct.
It does something very stupid.
That is correct. Now, just before I pass it to Bill, we also are in a fortunate position at ICANN to have access to information from IMRS, ICANN Managed Root Servers, also formerly known as LRoot. And we see an immense amount of traffic. That has nothing to do with what the theory will say. It would appear, I'm trying to choose my words here, as if there is a lot of research going on the DNS. I'm using research in quotes and quotes, where people are doing all kinds of measurements, and we may be in the case where the measurement done by those researchers is actually more than the actual real traffic. So guys, if you do measurements, try to be a little bit cautious about what you are doing instead of inundating the root or other recursive resolvers. An example of that, a couple of years ago, we measured that about 45%, almost half of the queries at the root, were coming from Chrome derivatives, Chromium, and whatever they were doing, trying to see they are behind a firewall or whatever else. Simply they were generating close to half of the traffic to the root. And well, we have been measuring this in the last couple of years, and now they have changed the code and they are down to about 5–10% almost of the noise. So that's why there's some value in measuring this all the time. But it's a case in point that doing some very active measurements can actually perturbate the system. It's kind of Heisenberg was right. If you monitor something, you actually perturbate the thing. Bill.
So,
Who are you?
Bill Woodcock still. So Alexei was trying to put a very generous face on this and find a innocuous explanation that could hypothetically apply in a specific case. But this is actually a really big problem, and it's not because of browsers refreshing. You can do a query by hand to a unique address, and there will be a very long tail. And you know, this is not something that Alain has uniquely discovered. Jeff Houston has been, you know, measuring this for a long time also, and he's not using a browser that's refreshing. He's got code to specifically generate unique URLs and do a query, and then wait to see whether that query starts echoing back again, you know, days later. And it's that the business model of most recursive resolvers is to monetize queries. So if you send them a query, you are giving them your data, and then they need to turn that into money, and they turn that into money by selling it in bulk to people who then want to know what it was that you were going to look at. And so they go and they repeat those queries, figure out what the answer to that query was, and, you know, try and figure out stuff about it and turn it into money. So that's what's happening, and that is a problem that needs to be solved, and you can run your own recursive resolver if you don't feel like being part of that economy.
Thanks, Bill.
If no further questions, then thank you for your attention.
No other questions? Okay, thank you, Alain.
This is not a question, I promise.
Can Alain leave the stage? Sure.
No, I want to.
No, he can't leave the stage because he mentioned that you run the L route.
I don't run the L, but ICANN does.
Yeah, well, your organization runs the L route, sorry. And we just last year got one of the L route instances here in Tampere. So anyway, we want to thank you for sending us one of those.
Thank you.
Any more last statements? Thanks. Thank you again, Alan.
Thank you.
Okay.